Hello everyone, today we're gonna talk about vibration or oscillation. Basically, it is a phenomena where object moves periodically. I think I can explain it easier with an example, so let me give you an example. I think the most used example for explain vibration, that is a pendulum. We need a sailing, and then a rope, and then a mast. If we don't do anything, this mass will stay in this position. This is the equilibrium position. Okay. Now imagine if we put our hands to this mass and we move to this direction, so the mass will be on this position, and then we suddenly release our hand. If you try this at home or you have a nice imagination, I think you can imagine that this mass would move to this direction. It would reach this initial position, this equilibrium position, but it wouldn't stop there. This object will move again to this direction until it reaches a maximum displacement. Then this mass will move again, get back to this equilibrium position. But then it doesn't stop there. It will move again to new displacement until the maximum displacement. And then it will move again to this, move again to this, to this, to this, to this, to this, until it stops, right? Now, we can analyze why this thing happened. Basically, it is because this system, this oscillator, has two important characters. The first one is stiffness, and the second one is inertia. Stiffness is when an object tends to get back to that initial condition, to its initial condition. So when an object is subjected to a displacement, it will move again to that initial position. It's happened in the first part of the vibration. When this mass is moved to this position, so it has this displacement, this mass wants to get back to the equilibrium position. This is when the stiffness works. But then, when it reaches the equilibrium position, the inertia works. Basically, inertia is when an object wants to stay in their condition. When it is stopping, it wants to keep stopping. When it is moving, it wants to keep moving. So, because this mass is moving to this position, it doesn't want to suddenly stop. I am moving, so I still want to keep moving, the mass said. So, when the inertia works, this doesn't want to suddenly stop, but instead it moves to this direction. And then when it moves to this displacement again, the stiffness works and the mass moves again to its initial position and goes on and goes on. Every oscillator needs these two characters, because if we only have stiffness, let's say, this object will be only get back to that initial position when we give it a displacement, but then it will stop. There's no vibration, right? Then, if an object has only inertia, that object will be always stop or always move. It wouldn't vibrate. Usually we describe this thing uh, by an energy conversion from potential energy to kinetic energy and vice versa. When this mass get the maximum displacement here, it will have a maximum potential energy. But when it is in this position, it is stopped. Basically, the velocity is zero, so no kinetic energy in this position. But then when it moves, the displacement starts to decrease. Let's say the displacement is y because this is in y-axis, right? It starts to decrease, and then the velocity is increased. So in this case, the potential energy is converted to kinetic energy. When this object reaches the equilibrium position, it reached the maximum velocity, but the displacement is zero. So in this place, in this position, the kinetic energy is maximum, but the potential energy is zero, and goes on. So along the vibration, there will always a change in potential and kinetic energy. Now let's talk about the math. We often use mathematical model to describe any physical phenomenon in this world, right? We also can describe how vibration is with math, okay? So there are many variables I have told to you. First thing is displacement. When a system vibrates, you can see that the system has a change of displacement in respect to time, right? The displacement would always change over the time. Like when 1 second, this is gonna be in this position, and then in the 2 second, it will change the displacement to this, and 3 second and 4 second, and goes on. That's the first. And the second one, when vibration happens, there is a change of displacement in respect to position. In this case, we can see in the x direction. This displacement is changed along this x-axis. We can say that because in a certain position in x, there is a corresponding displacement. Like when x is here, the displacement, the y is here. When the x is here, the displacement is in here, and when the x is here, the displacement is zero. So we can make a mathematical model that shows the relation. Usually, of course, we can make it as an equal symbol between the change of displacement with respect to time between the change of displacement in respect to position. This one will be kept questionable because every object, every oscillator vibrates differently. And I have to warn you that this is not true, but this is just the illustration. I will explain to you more in the next video about this kind of relationship. This kind of relationship basically is an equation of motion. An equation that describes how an object moves, how its motion, how its vibration. I think that's for today's video. Thank you for watching. I hope you have a nice day and see you in the next video.